Okay, it says Unit 2 test question 1. In order to for a function to be differentiable at a point C, the limit as x approaches C of f of x minus f of c over x minus c must exist is the answer here. And so why is that? Well, remember, in order for a limit to exist, the left-hand limit and the right-hand limit must equal. So basically, as I approach C from the left, by building this is basically what you're doing here is you're building a secant line to the left of C, and you're choosing x values slightly less than C. And you're kind of building a secant line. And you're getting closer and closer. And so you would build a bunch of secant lines, getting closer and closer to C. And so you kind of imagine choosing some x value over here, building a secant line. And then maybe choosing one a little bit closer and building another secant line. So you're building several secant lines until you finally get almost infinitely close to C here from the left. And then you do the same thing from the right, and you would then have several secant lines kind of going in like this and like this until finally each one of those two secant lines end up becoming equal, more or less. If that's the case, then the function is differentiable, and the limits of the left and the right hand secant lines, uh, slopes of the secant lines, that is, exist, right? Or they're equal. They both exist, but not only that, they're equal, and so therefore the entire limit exists. Okay. Now, what does it look like when it's not differentiable? Well, here you can kind of see C here, and if I approach here, I choose various secant lines going along, and those secant lines are all like that. Whereas here, if I approach C with various secant lines coming like this, here's a secant line, here's one, until finally I get to C. You can kind of see that these two red lines that I've created here, they're not equal, okay? And so the slopes of them. And so therefore, this is what it looks like when the left and the right hand limits do not exist of the slopes of the secant lines, and therefore it is not differentiable under those circumstances. Okay, and so therefore, exist is the correct solution. Okay. Finite, you could have a corner, right? They don't necessarily have to equal 0, and they don't necessarily have to equal C either. They could equal C by actually C is an X value. The limits usually equal a Y value, but it could be the same value. But that would be just a coincidence. It doesn't necessarily guarantee differentiability, whereas this does. This guarantees differentiability if they exist.